Okay, so here we have a right triangle, and we know with a right triangle you have two legs and a hypotenuse. And you know those two legs, the sum of the square of those two legs. So if I squared these two sides, which make up the right triangle, it's going to be equal to the hypotenuse. So when we're looking at this type of problem here, and we see that we're missing a side, we're solving, in this case, we're solving for a leg. Okay? If we were solving for the hypotenuse, we would be adding, but in this case, we're kind of subtracting here. So I just want to fill out my Pythagorean theorem formula so I can see maybe even which pieces are missing. Now, if you look at this, we could say, okay, I have the 14 squared, which gives me 196, and I have the 18 squared, which gives me the 324. I could subtract the 196, subtract the 196, and get b squared is equal to 128. Now, in order to solve for b, I'll take the square root of each side. The inverse operation of a letter squared is to take the square root. So basically, square root of x squared is just x. Now, a couple things I want to consider is, one, I know that square root of 128 is in between square root of 11, or square root of 121, which is 11, and square root of 144, which is 12. So I know this result is going to be somewhere in between 11, so on and so forth. Now, simplifying the radical of this is important as well. And I could do it many different ways. One would be looking at this as a 2 and 64, which would be the quickest way because 64 is a square root, and I end up with 8 and square root of 2. You could look at this differently as, okay, let's say you used a 4 and a 34, or a 32, I'm sorry, and then you get the 4 and the 8, and then you break down the 8 into a 4 and a 2. Now, a couple things to consider when doing this is that, one, you have a number that repeats itself. So when it repeats itself, it just becomes that number. Another is that you have a perfect square here. Square root of 4 is 2. Now, all this stuff is basically coming out of the radical. The thing that's left inside of the radical is this prime number here we get square root of 2, in which we get 8 square root of 2. That would be our radical form answer there. Now, a little bit, or a cheat when working, I wouldn't say a cheat, a quicker way, is that if I know I'm solving for a leg, I know I'm subtracting the leg squared from the hypotenuse squared, right? So here's the hypotenuse squared, here's the leg squared, and I'm subtracting the leg squared, the hypotenuse squared, and then I end up taking the square root of that result. So one thing I could consider is just saying, okay, let me just take the square root of the hypotenuse squared minus the leg squared and get a result of 11.31 here. And that's how that fits in with just using the calculator, not having to take yourself through this. Now, you may end up on an SAT where they don't give you the calculator, so knowing this formula, which is given in the beginning of your math SAT section, they give you this formula, they show you the triangle with the A, B, C, they show you the A squared plus B squared equal, they show you that. But solving for a calculator, solving without a calculator, just knowing your perfect squares is what we did here, and then knowing the radical form, which is basically how we broke that down there.